Hello amigos, so let's get started with gravitational potential difference and gravitational potential energy. And just before that, write these down constant parameters that are frequently used in spacecraft dynamics and gravity. Note them down safely somewhere. Also, just note down these unit conversion and standard values. These are frequently used in your propulsion, aerodynamics and flight mechanics numericals, and keep it in SI units only and solve your numericals. And now let's start with gravitational potential. So we have this gravitational potential over here. Just a second, so we have this gravitational potential, and which is defined as amount of work done on a unit mass when brought from minus infinity to a point closer to the earth at a distance r, okay, which is given by minus d m by r. And gravitational potential energy is amount of work done over a mass m when brought from infinity to a point closer at a distance r. They both are same, only difference here is unit mass and here is an arbitrary mass m. We can also define force as a gradient of potential energy, because gravitation force is a conservative force, therefore we can define it in terms of potential, which is the gradient of potential over here. And also you can note, if you integrate, we have force into distance, which is actually the potential, or say work done here. Also, gravitational potential energy near Earth's surface is given by U equals mgh, or if you substitute value of g, gm by r square, we have gmm by r square into h, which is also equal to uh minus u at height equals to 0. U at height equals to 0 is not 0, which if you see over here at h equals to 0, you will find potential energy to be 0, which is not true, because as r tends to infinity, there is no gravitational influence, so there will be no potential. And if you come closer to the Earth's surface, you will start feeling the influence of gravity, therefore you will feel some potential, the amount of work that can be done, okay, on the mass m. Or if you see over here at r equals to radius of earth, we have some potential, and this is the potential axis, and r equals to radius of earth, or say at u at h equals to 0, because at radius of earth at height is 0, u at h equals to 0 is not 0. We have shifted this reference over here for this formula, but in actual, for this potential energy, we have reference at infinity. For this u equals mgh, the reference is over here at h equals to 0, that is at radius of earth. So the only difference here is this formula, that is shift, which is given by UH minus UH equals to 0, which is equals to mgh. Now we have this gravitational potential difference, which is delta U equals UB minus UA. Delta U is actually the potential energy at B minus potential energy at A, which tells us about the amount of work done that needed to be done when object M is displaced from position A to B, okay, which can be computed from this as well as from the graph from this shaded area. And now we have this m1, m2, m3 set of masses kept at a distance from each other, 2d, d, and 3d respectively, and the total gravitational potential energy stored in this system is computed by the sum of each set, which is u12 plus u23 plus u31, and u is given by this formula, which is gmm by r. R is this over here, 2d for m1, m2, and similarly we have this for other two sets. And lastly, we have this inverted bell shape. It is actually the potential energy lines which are converging towards the CG. And if you observe, potential energy keeps on decreasing, that is, it has maximum value 0 at infinity. Okay, if you substitute r tends to infinity, it will have 0 value at infinity, which is maximum, and as r tends to infinity, it tends to 0, approaches 0. So which is why we have gravitational potential lines converging towards CG, towards minus infinity actually. And on the other side as well, if you see, gravitational potential lines will approach towards CG, or actually minus infinity. And at a height h, gravitational potential energy is same, we know. So at a distance r, or say at a height h, we have same potential energy, which is represented by these gravitational equipotential lines, red lines, circular lines. So these in combined gravitational potential convergence and these constant lines, gravitational potential constant lines, form an inverted bell. And thank you for this.